What's going on, guys? In this video we are going to talk about cross product of a vector function. Let's look at the multiplication of a vector function. For a vector function, we can multiply a vector function by a scalar, and if you do that, the final product will be a vector. And also we can multiply, let's call this vector function like a, and if we multiply this vector function a with a scalar, that's going to give us a vector. But if we multiply a vector function a by a vector, there are two ways you can multiply. You can multiply using dot product, or you can say scalar product. And if you do that, vector dot vector, that's going to give us a scalar. And if you multiply this one using cross product, or you can say vector product, you're going to get a vector. This is what we are going to look for. We are going to see how we can find out what's going to be the cross product, how to calculate a cross vector. Okay, now let's look at a vector function. Let's say we have a vector function a that has three components in 3D space. It's going to have three components. So ax I hat, and then plus ay j hat, and then az k hat. Okay, and another way you can write this one also as ax comma ay comma az, and a good way to think about this one as this as a row, like to get this one back, ax ay az as a row. And if you put this ijk components in columns, jk components in column, and if you do the multiplication, like if you remember linear algebra, row times column, you will get this one back, right? And that's another way to think about this one. And in order to do the cross product, we need another vector function. Let's go ahead and create another vector function. Let's call that one b. So b is going to be equal to bx I hat and by j hat bz k hat, and that can be written as bx by bz. Okay, and when we do the cross product, a cross b, that is equivalent to a magnitude b magnitude sine theta. When we do this for dot product, we have seen that this is a magnitude b magnitude cos theta, but for a cross product, it's a magnitude b magnitude sine theta. So when we talk about cross product, like a dot product, it's giving you the answer in cos theta. It means it's saying how parallel the vector it is, how parallel or anti-parallel the vector it is. But for sine theta, it's different. So if we say this is a, this is b, and if this is theta, that's going to give us a magnitude b magnitude sine theta. Now let's see how we can do the cross product. Let's get rid of this one. Okay, let's continue somewhere here. Let's continue this one right here. Okay, so when we cross product, it's similar to finding the determinant. If you remember a cross b, that's equal to the determinant, right? Determinant, and this is going to be a 3 by 3 matrix. 3 by 3 matrix. Now let's see how it's going to be. So first we put ijk components, ijk, and after that we put the values, like for I we have ax and jay, then kaz. For b vector we have bx, by, bz, and if you remember the determinant for 3 by 3 matrix, we put a plus minus plus. Let's look at the determinant for 2 by 2 matrix. For a 2 by 2 matrix, if we have a, b, c, d, the determinant is going to be equivalent to ad minus bc, right? So this is our determinant. But for 3 by 3 matrix, what we do is first we completely, like if we take this one, we completely eliminate all the horizontal and the vertical part, and we are left with this one, right? So from this one we have to find out what is AD minus BC. Like you have to look at the position A by BC, similar to this, A by BZ minus AZ BY. So this is in the I, because we took I, and when we take I, we eliminate all the horizontal of the I and vertical of the I, and then we are left with this 4. Then we do this similar pattern AD minus BC for that, and that's going to be our I component. And we do the same thing for J component. When we take J, we eliminate all the vertical and horizontal part of the J, and we will be left with this 4. So when we do it for J, this one will be eliminated, and we have to do the same thing for this one. So that's going to give us what? AX. But for the second one, we have to put a negative sign in front. When we do the 3 by 3 matrix, plus minus plus. So this is negative. And then AX BZ minus AZ BX. So this is going to be the second one. For the third one, we do the same thing. So that's going to be plus because it's plus. And then that's going to be what? AX BY minus, this is going to be AD minus BC. So B is the position here. So AY BX. And that's going to, this is J component, and this is going to be K component. And that's how we do the cross product. This is equivalent to A cross B. And that's how we do that. I hope this helps. Thanks for watching.